Hey Venna, klokken Redmond og til .NET API Review. Selv om vi har mange problemer, har vi et komma ignemum to I dag. If anyone speaks Danish, let me know how I did. Alright, for those who don't speak Danish, including me, today we're just hoping to get through Tensor of T Part 3 and standardized pattern for exposing advanced configuration for compression streams, and, well, we'll see how we do. Alright, Tensor Part 3, 104117.
Can you hear me?
Yep.
Yep. So this is a continuation of the many tensor reviews we've done so far this release. Continuing off where we left off last time, we had some questions about mean, um, in particular whether mean was the right name, and whether it was actually just average, like what we use in Link and other places. I talked to Michael, and it sounds like this is actually just average, and so we could name it just average like we do in Link, with the note that it was picked mean because that's what Python uses, but .NET uses average here, so consistency with ourselves first.
Alright, mean to average.
Um, then we have the is APIs, which we had discussed briefly last time. Um, and in particular, we had said that that while the simple form for just the ones that return the vector is probably makes sense, there was some question on whether any and all as suffixes were the correct choice. There was some discussion on whether those should instead be, for example, all pow2 or is pow2 all, and which was better. We just wanted a couple more people to weigh in since we had deteriorated to like two people near the end last time. Um, from what I recall, we were kind of leaning towards, even though it's not necessarily grammatically correct, just being consistent with how we've ordered all the other APIs and doing is pow2 all and is pow2 any, for consistency. But there wasn't a strong preference on either direction because they both end up wonky in one way or the other.
I don't suppose any offline feedback was elicited on these.
No explicit offline feedback was gone for.
Okay, because I feel like we were late because it was a Thursday and probably late on time, and we're a little late right now because it's a Thursday, and so I don't know we're actually getting any better or different opinions than when we were stalemated last week. So, I guess we get to doodle it up here again and see if it wants to make anybody scream one way or the other. Actually, I don't know what your single version would be.
It'd still be just is pow2.
Is Pow2 taking a tensor span?
Yeah. So the one that would just be
Oh,
called is pow2 would
this would be
would
the one returning a
return
tensor.
the yeah.
And then the one that collapses this down is that.
So it's
And does anybody hate any of these more than any of the others? Oh, and I guess we need to duplicate it for any.
yeah, and with the note that the reason why is-pow-to all and is-pow-to any are the default presumption there from the proposal perspective is because that's the format that we used for the comparison operators where we have compare equal all, compare equal any, we have greater than all, greater than any, greater than or equal all, greater than or equal any.
I thought I saw Emo's mouth move, but I haven't heard Emo at all this meeting. Wait, I know vowels. Emo.
I haven't said anything. I was
Yeah,
just
okay.
coughing my lungs out apparently.
Fair enough. Um, I mean, if we can't get anybody to give an opinion on this one, then we get to punt it again.
It seems reasonable to me.
What does?
Well, basically the original proposal.
So just sticking with the is and putting an any and an all on the end?
Yeah, because I mean, grammar, yes, but I feel like I don't know, like the general pattern of those APIs seems to be kind of going down that path, right? I mean, any and all, the problem with those is we don't have that many APIs to begin with. But I don't know, like at least in my head, it seems if you ignore, let's say the link APIs, it does seem kind of just more a modifier of what is happening rather than the core of the thing. You just basically ask is it a power of two? And then you basically say, well, is that true for all of them or is that true for any of them, right? Which is why I probably would do the is-pow all and is-pow any.
Fair enough.
But we also seem in the territory where people don't care that much. We probably could call it almost anything else.
Can you hear me now?
Yep.
Yep.
Okay. My microphone was not working.
So we're yelling at us the whole time then.
No, I had given an explanation of why they were the way they are, because we've got the existing greater than all, greater than any, and so it's the existing suffix that we've got on the comparison. The reason that they're a little bit different is just because the is, and my own preference is, even though the others read a little bit more grammatically correct, uh, we have a pattern now that fits, and so being consistent there makes overall more sense. Given hindsight, we might have even named the greater than all, greater than any um, differently, and maybe we could have done any greater than and all greater than, and those would have actually been better from day one. But we're about 10 or 11 years too late on that now since we since we made that decision for those ones back in 2014.
So then this gets here.
And notably, you're missing one overload there, which is the Is-pow-to that, and I posted it in chat. It returns tensor span of bool, and takes in the tensor span bool destination.
Yeah, you wrote that one twice, actually. So is
Oh.
my top line right? And I
Yeah,
should just duplicate it with yours.
yeah, your top line is correct. It's the other one that's missing.
And then are these actually named X?
Yeah, the first one's named X and the latter one's named destination, which is the
No, I just mean in
decision we
for
made several
is
reviews
pow2
back.
is canonical. Are they all X?
Yeah. Yep.
What does scope do on an in? I thought scope is more for out.
The scope, so the return type of that second one should be tensor span. The scope then says that the return will never be X or the data that X points to. Basically, it's saying that X won't be returned here.
Oh Jesus, that's what scope means when you take parameters that you can't return it?
Yeah, scope basically means that this one's never going to be captured as part of the output, or captured inside the ref struct in case of an instance method.
Yeah, and like here, this is also scoped. You just don't have to write it down because this guy could never be contained within this guy by ref struct rules.
Yeah.
Yeah, because tensor of t is a class, right? Not a ref struct.
Yeah. So it's when you have a ref struct in and a ref struct out. Scope says they're not the same struct. Or they're not the same ref.
And scope only applies to spans. It doesn't work for anything else.
It applies any kind of ref parameter.
Struct, yeah.
Yeah, so ref struct or just a regular biref in the case that because if you just had like a ref t and you were returning a span, by default the presumption is that the return span could wrap that ref and therefore extend its lifetime.
I see.
So you want to say scope to say that I'm not going to extend this lifetime. It's going to be limited to the context of this method only.
Right.
All right, and tensor primitives, presumably.
Yeah, same overall shape,
these...
except there is no returning tensor. There's only the ones that deal with the destination. And on tensor primitives in particular, because there's no composability consideration, these are primitives, they're void returning.
So the Is-pow2 and the ones that take a destination are void.
Yeah.
But you are still collapsing down to the single bool because
Yep.
Otherwise they wouldn't be here. We would
Yep.
have already approved them.
I have to say, I really dislike is methods that return void, but I don't have any smart other ideas.
Yeah. I think that the saving grace for these ones is just that they're on the tensor primitives. They're fundamental building blocks.
Yeah.
And so they're meant to be more low level.
All right. Seems like we have patterns no matter how much we don't like them.
Yep.
Going once. Going twice.
So we're using is over R.
Yep.
I'm fine. Yeah, I prefer that personally. Who cares about valid English? No, yeah, it sounds fine to me.
I mean, the reason why I think is fine is because once you drill in too much, it becomes confusing. But given that you basically treat the tensor all up as one value, logically, right? You treat it as one logical entity that just happens to be comprised of a ton of smaller values. It's really hard to say when R and when is would be appropriate, right? So you might as well just say we always use is.
Yeah. And then from a consistencies perspective, what you basically have is you have just t, the scalar, then you have a vector of t, which is the acceleration primitive, and then you have tensor of t, which is the collection primitive for those, and they basically compose on top of each other. So when you have all three of them being consistent, you basically have one world that you can tell users on how to operate with it. If you want to operate on a single value, use T, and you use Is-pow-to. If you want to operate on, if you want to accelerate many of those using the acceleration primitives, use vector Is-pow-to. And then if you want to do it with tensors because you don't want to deal with accelerating it yourself, well, then you have tensor Is-pow-to. So it's a consistent grow up story where you don't have to say now the concepts change from domain to domain.
All right. I think I got that pattern right.
Yep. Notably for the vector one, it returns vector of t, not vector of bool. For the isfoo one, uh,
Huh?
because they return the bit mask, not the bool result.
Which again, that would make the any and alls also bool likes, right?
No, for those ones they do return bool because they're doing the extra step of going from the raw instruction, which returns a per element mask, to returning an actual bool that users can use in the operation. Whereas for tensor primitives, and for the scalar, it does return directly the bool, um, because those ones are the higher level concept.
You know, throw in some more likes to make it even more patterny. There you go.
There
Vector like of a bool like. All right.
Yep.
Precedent is established.
there, yeah.
So we're done with tensors? For
No, no,
9?
no. You missed you missed the other half of the proposal here.
Oh. Okay. Well, you had. I hit. Basically, I hit copy, whatever, and then when I hit the end
Okay.
of the buffer, we're at the end of the proposal. Like, these sections
Yeah,
things, they're just confusing the host. So.
it was specifically split because there was the parts we had already discussed and then the parts we hadn't discussed at all.
Fair enough.
Yeah. Okay, so this next part is there's no more tensor primitives consideration here. This is the thing. This is the concepts that are unique to tensor of t itself, and so this is where there's going to likely be a bit more discussion because of there's some new concepts at play and some new considerations at play in terms of naming and things like that. Um, so the first two in the list are pretty simple. They're just as read-only tensor span and as tensor span. The actual name there would be spelled out, not RO. as per the last review, it was compressed down because we were hitting the comment length limits for GitHub. But they take in the T array, and then they take in a params span of the lengths that are used to construct the dimensionality of the and shape of the target tensor span. And so those are just the extension methods for having an array producing a tensor span from it.
Do we really want that as an extension method on all arrays? Or do we want someone to just have to walk over and say tensor dot as tensor span of array / tensor dot create of an array?
Since it's under the system numerics tensors namespace, they'll only appear if you've already imported system numerics tensors. They're not going to just appear for everyone writing code.
I feel like every time we say that, we then say, but VS made some change at some point, and IntelliSense now shows them across all namespaces that it can find anywhere in the universe.
I don't think it does that for extension methods. It shows it for types, though.
Okay. Alright, I went ahead and updated this one in the notes that I'll update now that I realize there's a second half to part 3 to expel out read-only in the method name, just so we don't think that we approved the name with, or this with a truncation, because obviously this has to be read-only span, because we're not making a new type.
Yeah. Then we have the broadcast APIs. So the terminology used for what a broadcast is varies based on hardware and some other considerations. Some people use the most common term ends up being broadcast, but others use the term splat or something similar to that name. But the terminology that we've got for the x86 hardware intrinsics, the ones that we've used more consistently for the cross-platform intrinsics, and then the terminology that other libraries like Python or Julia or others use for their tensor libraries is broadcast. And so we're using broadcast here because it's the most consistent. And so this simply takes the dimension specified from the input and then replicates it across all dimensions of the output. So the simplest example, if you have a scalar t and you broadcast it to a matrix 4x4, then every element of that matrix 4x4 is the input x. And if you were to broadcast a vector across, like a vector 4 across that matrix 4x4, then every row has that vector as its value. And then the ones that have a destination, those ones, the ones that explicitly take in a destination instead of creating one, we call those broadcast to match the naming of copy to and other APIs that work in a similar fashion.
Did we already do this on vector?
On vector, we just have the method named create. It's a little bit simpler for vector because there's just the one concept. But this is also a case where that was for vector, the decision was made back in 2014, and we were being consistent with that. Broadcast would have been a probably clearer or better name. And we just couldn't do it at the time. For Tensor, it ends up being confusing because there's not a fixed length, and the shape of the tensor could in fact be something like one by one, and therefore you can't just have create that takes a t and assume that it means broadcast. You need to explicitly specify for the tensor, I'm wanting to broadcast this input to the destination shape.
Yeah, I mean, really, I'm just questioning why there are extension methods here on non-generic instead of instance methods on the types.
It's the generic explosion issue. We don't want instantiations to be created for these methods unnecessarily. We want them to only happen when the users actually
Use them.
Yeah, when they actually use them.
So returning to this previous note, several people in chat say that it seems to be an option in VS of whether or not to show extension methods from unimported namespaces, and in a clean install VS, it's on by default. So a clean install of VS will say that all arrays have a dot as RO tensor span, well, as read-only tensor span.
Interesting. Yeah. On one hand, there's the friendliness of being able to use the as read-only tensor span method. On the other hand, there is the implicit conversion that exists in using. I would say if we didn't have these as an extension method, then we would just want users to use the create method. Just do new tensor span array, comma, lengths. Regular span has both options where you can either do new span passing in the array, or you can do array.as span, with the latter being the much more prevalent and convenient option.
Well, normal spans have an extension on array like this, right?
Yes, but normal spans we've said are a core part of the
that's what I was
language.
just saying.
Tensors, I believe we feel, are niche. So the question is, does this need to be in the face of everyone ever using an array? For spans, we said yes, because if you're using an array, we think maybe you wanted to be using a span instead. More or less. So span is we want to tell you it's here, and we want you to move lower, and tensor is this is just different, and 99% of people probably will never use these types.
Yes, my only thoughts with that is we have made certain decisions in the API review process saying this is what we do for span types, and so this is what we're going to do. And it seems like we'd be breaking that kind of trend if we change this, but I'm always fine either way. It just seems kind of odd that for some things we're saying this is how we do it for span, so this is how we're going to keep doing it. But in this case, it's a niche type, so we can.
Yeah. Well, I mean, it's the whether or not we put extension methods on, array and string, and I mean, we should never put an extension method on string, but well, that's not true. It's whether or not this type is worth messing with core types, and saying we start with the same approach and then decide when it's different is I think a reasonable stance. And so I think if VS is being unfriendly, and in what I would call unfriendly, and showing by default extension methods across all namespaces, I think we should omit these friendly entry points, personally.
My stance would kind of be the opposite there, which would be that we should design this as if users didn't have an IDE, and we should design it for how users will actually expect it to be composable and usable. And the fact that VS has decided to start showing more for discoverability reasons, presumably, shouldn't mean that we should make our own API surface worse because they're deciding to start showing everything to the user. Presumably, they've got data that has said that overall users prefer the experience of seeing everything, even if it's not directly imported or necessarily relevant.
Emo?
So I didn't pay actually any attention.
So the question is the top two methods. If VS's default experience is show all extension methods regardless of what your current using scope says, do we think that we want tensors showing up on arrays for everyone, or do we want to cut the extension methods and say people have to call create or new tensor?
I mean, considering that the API is like the method themselves is kind of telling you what it does, I don't mind if it shows up. I mean, it's also going to be in a NuGet package, right? So it's not referenced by default, or am I wrong?
Yeah, right now it's not in box.
I mean, for anything that's not in box, I would say once you reference the NuGet package, I think it's fine. I mean, in general, as APIs, I think people understand that this is, a type conversion. So unless you care about the type, well, you just ignore it, right? I mean, it's not really any different from all the other APIs that show up. Like, to me, arrays they're kind of primitive type, but they're also somewhat specialized. What I really dislike are extension methods on object. Like, I don't know, all some JSON APIs do this for parsing and serialization, which to me is terrible. Because then it's like every single thing you have is now this thing. Versus arrays, I mean, once you got into arrays, I think it's reasonable to have those APIs on there.
Fair enough. All right. So, and then these broadcast twos. You said this is the keeping the surface of a generic type reduced, especially because it's expected to be used with value types, which means it's going to be pages and pages and pages of dead code. All right. So that brings us back down to concat.
Yep. So concatenate. This one, it concatenates the tensors. There's a little bit of nuance here in what axis means. Michael and I were discussing whether or not it made sense to have the axis parameters or to explode it out, and I was leaning towards exploding it out because the functionality when the axis parameter appears is a little bit different, whereas Michael had been leaning towards keeping the axis parameter because it's overall more convenient for users to access. There wasn't a clear goal there, or a clear outcome there. My own thinking was that because the functionality when you have the access parameter ends up being slightly different, that in many cases it would lead to potential versioning problems over time, where if we were to add another parameter, what would it mean then at that point, because the functionality is technically slightly different. What the access parameter does is it basically says, for this dimension in particular, do that operation across all elements in that dimension, rather than, and so it kind of works as if you had first sliced the input tensor and then done the operation. Anything you want to add there, Michael?
Well, that sounds about right. Yeah, so concatenate, right? So everything that says axis is going to be changed to dimension, right? That was the feedback from the last one. So that'll actually be what it is, parameter name wise. But yeah, concatenate. If you don't provide an access, it concatenates everything, but it like concatenates to a single dimension. Where, as Tanner said, if you provide an access and an axis, it'll then do it on that axis. So I'm fine exploding it out or not. I think it is more convenient to have it in one method, but I think either is fine.
I didn't follow any of that, so whatever.
Yeah, so effectively we want the concatenate API, but there's this repeated concept throughout here where there's this int access parameter provided as an optional. And the consideration there is that when an access is not provided and it's the default, that this operates exactly like you think it would. So it expects that the input tensor, or it takes all of the input tensors and it concatenates them together just like you would for a string effectively, and produces a new tensor that has an additional level of dimensionality. So you go many 1920 by 1080 images, and you end up producing one tensor that is a 19 by 1080 by n tensor, because you put them all into the same buffer effectively, concatenated them. When you provide an axis, the dimension, instead of concatenating them, it basically decides where the concatenation occurs in the dimensionality. So by default, that happens where you're adding to the largest dimension. So you're going from 19 by 1080 to 3 by 1920 by 1080, or whatever. But if you provide a dimension, then you end up in saying that instead of concatenating the entire tensor, you're concatenating just these dimensions. And so you might go from a 1920 by 1080 to a 1920 by n by 1080 if you said the dimension was 1 instead, because you're specifying which dimension you're doing the concatenation along. And so they are they are both concatenations, but they are in some ways distinct concatenation operations. And the question was whether they should be one API, concatenate, which takes an int dimension, or whether they should be two APIs, concatenate and potentially concatenate along dimension, or concatenate something along that name.
Gotcha.
And we do have this scenario that comes up several times. So if we do want to split out the APIs, we should probably see if we can figure out a good naming scheme for these types of methods, because it is going to come up several more times.
Yeah, and the name that came up to me for these was basically you have X and then X along axis or along dimension, because that's effectively what you're doing, is you're changing from a concatenate to concatenate along the dimension, or you're changing from reverse to reverse for the given dimension.
I was thinking on dimension, but along dimension seems reasonable, especially if it'll work with all your other verbs better.
On sounds good too. Yeah.
And then, so Michael said all things that say axis should say dimension.
Yeah, because that's the name.
Decided
Sure.
any.
Okay, just I did
Go
that
ahead,
bulk change.
Michael.
I was just making sure it was
Sorry.
correct. So.
Okay.
All right.
Yeah, we had said it in a previous API review, and it just didn't get updated in the proposal here.
So in that case, it seems like we can go with the comment here that says they wish that this was params. And then
Which one was param? Sorry.
the span of tensors.
Yeah, there was a comment that the parameter order feels slightly off because if you didn't have the so because the dimension was defaulted, we couldn't have the tensors be params, meaning we couldn't allow users just pass in however many tensors they wanted. But with it split, we get the added bonus that we can move dimension to the first parameter and we can keep it params, so you can actually have a slightly nicer surface area too.
Yep. So, what do you want to do with the destination writing one? If you
That
want
one should also.
if you want it params, it's
concatenate and concatenate on dimension.
right. But if you want params, then
Oh, yeah.
destination needs to move left. So then it'd be concatenate
I
destination.
think for
comma,
that one,
Go ahead.
yeah, I don't remember what we've done for our other APIs. I'd almost say that because this one is specifically trying to be allocation free. Well, actually, that's. I think for our consistency, so for our consistency rules, we'd end up saying that destination needs to come first, because otherwise you get into an issue where, if you passed in one tensor, it overloads to concatenate the params one, but if you passed in two, it overloads to the destination one. So that might throw a wrench in being able to use params.
Tensors are implicitly tensor span.
Tensors can be implicitly cast to tensor span, yes.
Okay.
But I guess the T itself couldn't be a tensor. Actually, it might be
No,
but that
would
wouldn't
be
cause a conflict.
tensor A comma
So-
tensor B. No, because in this shape, if the span of tensors has to come first, then then A comma B would only be this guy. Because
Right. Because we end up then having a tensor of tensor of T, so it never conflicts.
and then in fact, if you made this concat, if you moved destination to the left so you could go params, then A comma B could now be this one, as well as the top one.
No, it wouldn't, because you know what T is, so therefore you would have, let's say that T was itself a tensor of T, then you'd have a read-only span of tensor of T and a tensor span of tensor of T, which are two distinct things.
No, I'm saying if we change this, if we move destination left and turn this into params read-only span of tensor of T, then a call where you call it with two tensor of ints, it would see, oh, this first tensor of int could become a tensor span, and the second one, I guess you're just passing one thing into this params.
Oh, right.
Or you're passing two things into this params because of the implicit conversion. It's where implicit conversions start being a cost instead of a benefit. So I think the destination writing when not being params is fine. And then, so for on dimension, where do you want the dimension parameter to go? On this one, I had to go first because params.
Still first parameter.
All right, so you think?
Yeah, I'd say still first for consistency across overloads.
And once you've said on dimension, it clearly is a formal parameter. So. And then how's somebody supposed to know what dimension means? So they have to know.
Yeah, we're going to end up writing documentation, XML doc comments that explain the concepts, because these are kind of a little bit more difficult of a concept when, but like there's no simple way to explain it. So we're probably going to have a small diagram explaining here's how concatenate works across a dimension with an example code.
Yep. And we'll probably end up doing that with all of our dimension ones.
Right. Just the way you were explaining it, of like, oh, if you concatenate 0, that'll make a new dimension. If you concatenate 1, and I'm like, oh, then that'll do it along the 1920, and then you're like, it'll do it along the 1080, and I'm like, well, now I'm confused. So, so yeah. Just
The reason it's 1080 is because the order you read the dimensionality for an image like 1920 by 1080 is the inverse order that the parameters appear, which is a 1920 by 1080 image is a 1080 comma 1920 array, because you end up doing row major for the actual
gotcha.
for the actual
So it's, you had the rows, or you have a row, then you make an array of rows, and then you made a stack of arrays of rows, and then okay. Fair enough.
We read Cartesian coordinates as little Indian.
Fun times. Yeah, so chat pointed out that the current implementation broadcast calls these input and destination. Should these just be called source and destination?
Yeah, probably. I think that's fine.
And then similarly, concatenate, do we feel that those are source parameters, or do you think tensors is a better name?
I think tensors is better because it's not just one source, it's many sources.
Fair enough.
And at that point, tensors is more descriptive than sources. We then have the create APIs, which actually create a concrete instance of tensor of t. We've got the various overloads here. So we've got the one that takes in the read-only span, specifying the shape. We've got the then optional pinned parameter. The pinned parameter being optional matches how, for example, the GC allocate array API works. I wouldn't care if it was explicitly exploded to be two separate ones. But we do want the ability for users to say that the memory we allocate here is definitively pinned. And then we've got the overloads that take in source values as an array and source values as an IEnumerable.
Why do current lines 100 and 102 not share in pinnedness? That with the current shape, if you want it pinned, you need to also specify strides?
Because yeah, I think we had said that we wanted that because we normally have a rule that two overloads that have the same overall parameters shouldn't both end with optionals because of potential conflicts, right?
Although I guess that is definitely the starting
place. Have
place.
the very first one on line 98.
Right. I mean, the only have one with defaults is the easy position to make sure that you don't end up with conflicts. The real answer is don't end up with conflicts.
Yeah.
Since the is
okay. Yeah,
since the
I
pinned,
don't mind if they're also there for convenience.
Since pinned or is pinned, and we need to pick a name and stick with it. Since those would never conflict with the strides parameter, it's not a problem.
Yeah, I mean, if we can explode
Looks
them out,
like
I would prefer
for-
to. Oh, go for it, Tanner.
No, go ahead. You were talking.
I was just gonna say, I think personally, if we can explode them out, I would prefer to, because a lot of the code that I've been writing, I end up needing to pass in if it's pinned or not. I mean, like most of the time it's false, right? But like I just have to propagate that on, and so I end up having to provide strides, which I either then just have pass in the default value, so it's auto-calculated or whatever. But like it ends up being something extra that I have to do a large portion of the time, and so I think it'd be good to have that, uh, the pinned bool without needing to provide the strides, because I think that users will pin a value or pin a tensor more often than they will manually mess with the strides.
Okay.
And then I think pinned is the better name because we're not saying it already is pinned. We're saying whether it should be created as pinned.
Yep. It
And
also
that's what
matches.
GC allocate array did. It just named it pinned.
Yep. I had just looked that up, and that's why I started. That's why I got rid of the is pins. So.
Yeah.
Okay. But yeah, so this bool can never conflict with that span. This bool can never conflict with that span, and this bool can never conflict with that span. So I think this is fine. There's no ambiguity in the structure. So read only
then
span of links. Wait, that shouldn't be links. Should it?
yeah, that one is lengths. It's specifying
Because you're skipping
The-
the first parameter.
the basically the value of the length parameter.
So that's creating
No,
it
no,
as
that one's
zeros?
just creating a zero length. Yeah.
Right. So this is creating it with the right dimensionality, and zero filling it.
Yep. Whereas the overloads that take in a T array are specifying here's the source data.
Okay, so you take this as a T array, because I simply read this as they were all the values parameter of this is your values as a span, here's your values as an array, and here's your values as an enumerable. So why don't you have one as a span? Is that because that's just the existing constructor?
I think it's just oversight. Too many APIs that exist and simply missed the fact that there was a span one.
I guess I'll call it RO for consistency. Alright, so if T is inint, do we have ambiguity? No. You could have confusion, but not ambiguity.
Yeah.
Because if somebody had a span of inits and they called tensor.create, they're getting this one and maybe thought they were getting this one. Well, that's what you get for having a span of inits. Alright, so so these four can all validate links against values a priori. What does this do if values
Yeah, that one.
is short or long?
The
Uh,
unnumbered ones.
It's so yeah, so go ahead, Michael.
I was gonna say, if it's long, we just ignore the other data. If it's short, we throw an exception.
Which is how vector APIs also work. They allow too large inputs and they only read the first n elements. If it's too small, then it says, hey, you didn't provide enough data, throw.
Fair enough. Okay.
Yeah. Now, the next one, I'm going to skip create and fill real quick. Create uninitialized is a little bit easier, and then I'll get to create and fill because that one pairs with the ones after create uninitialized. So for create uninitialized, it's exactly what you think. It's create, but it's saying explicitly, I don't care what the input is. I'm going to fill it in myself. These could be arbitrary values for a value type T. So it's a conceptually unsafe API. Uninitialized is the term we used in GC create array uninitialized, so it's the suffix that I opted for here as well.
Seems fine.
Yeah.
Yep.
Now for the create and fill ones, those ones are effectively equivalent to create uninitialized followed by a fill call. They're there so that users don't need to worry about potential unsafety about creating an uninitialized piece of data. There are the two most common fill APIs. Long term, I think that we want a different shape for this, potentially something that's closer to the string create API that takes a callback. That way, users can trivially create and fill at once using uninitialized data. But these two in particular are very important for tensors from the point that we ship, as they're the most common seeds needed.
Okay.
Gaussian normal distribution is filling it with a normal Gaussian normal distribution, and uniform distribution is basically filling it with random data that's uniformly distributed across the input domain.
And one comment with those that was called out in the issue is we should allow a random to be passed in so that they can be reliably reproduced. So that does need to be right. We can either pass in a seed or pass in a random, but we need to be able to have something in there.
All right. I want to pause this and pop back to create because chat has pointed out there is a conflict. The two highlighted methods are the same if T is in it.
Yeah.
So I guess that's cut the span ones.
Yep.
Or-
I'd cut the span ones, and users can have other options.
I mean, I guess you can also just cut the span one that doesn't take strides, but that might just be confusing. So
yeah.
So maybe that's why you left the span ones out. All right. Right. So when you say your uniform distribution is over the range, because you know it's a floating point. I was going to ask,
Yeah, so
how do you know what the range is?
Yeah, so it's 0 to 1.
Okay, so not even the range of the input domain of its thing defined as 0 to its thing defined as 1, and using blitting.
Yeah, random shared.
So, but random shared can't give you a Tanner's custom awesome floating point, which can implement floating point of T. So you're clearly using generic math create.
It's the relevant generic math methods exist to be able to ensure that the uniform distribution, the way that random itself works is it effectively gets the number of mantissa bits as or the number of significant bits as a integer, and then it divides that by one, and that's effectively how sampling works for random. And the same all I floating points specify the number of significant bits they have and their base exponent. And so we can uniformly use random to ensure we get enough bytes of data to construct an integer represented as the target floating point type, and then divide that by to ensure it's a normalized distribution across the 0 to 1 domain.
Okay, I mean, I'm just like, I don't know. I work in cryptography, so system.random is always the wrong answer. I'm just trying to think, what are the does our random class even provide this? Because I thought it was built on the notion of either float or double 0 to 1.
Well, no, so technically speaking, it's not built on float to double. It's built on get bytes, which just gets it's n times 8 random bits. And then the way next double works itself is it says double has 53 mantissa bits, or significant bits depending on the terminology you want to use. So take the first 53 significant bits that were generated, multiply that by 1, divided by 1 left shifted by number of significant bits. And that gets you a uniform distribution within the range of 0 to 1. And for double, it does the same thing, but instead of using 53, it uses 24. And all floating point values, all I floating point values, provide the information about the number of significant bits and their radix. So you can always say, I have a distribution along a power of x that is uniform, and therefore you know what the window is between 0 and 1. And so the same algorithm works for any I floating point type for getting a uniform distribution given. You just need to say, I need n bits of random data to start with.
Fair enough. So my mistake was I thought that random had only one abstract member, which was sample, which is what returns a double. And then apparently that's not abstract, that's virtual, and we have a whole lot of virtuals, and random is like stream. It's a thing of good luck writing it correctly. Okay. But our default implementation does implement it in terms of bytes. So I didn't mean to scroll this one.
Yeah.
All right, so yeah. I mean, really the question is how many overloads do you think are appropriate, and then we get to argue about them.
Yeah, I think it's just create and fill Gaussian, create and fill uniform, and then in the future, if there's more, we're going to cover it with a generic create and fill method.
No. I mean,
that takes
Michael said he
predicate.
wanted a seed or a random or both or so.
Oh, yeah.
I don't think we need both.
I think in this case I think just the one that doesn't take in random and the one that takes in random is sufficient.
All right, so you don't want one taking a seed. If someone wants seeded, they pass their own seeded random.
Yeah, because all we could do is create our own random at that point. So,
and I assume you want it on both create and fill and fill.
yeah.
All right, so these clearly random comes first because you're params. You're also returning a thing. In fill, do we feel that that's a? It feels more like a
I'd be
trailing.
fine with. Yeah, it kind of feels like a trailing since you're providing the destination, and then we could just default it to null if we wanted to. Save a little bit on overloads.
Fair enough. I guess makes that a question mark.
All right, then we've got filtered update. This one is particularly interesting because the way that a lot of other libraries out there do this is they actually expose it as part of the indexer. Um, and they'll allow code like tensor x is less than 0 equals 5, just as a simple example. And basically what that will do is it says that for every element where x is less than 0, set that value to 5. That is functionally what this filtered update is doing, is it's saying that for every value in x, the corresponding filter has a true element, then set that to the value from values. Of course, this syntax does not work in .NET or C# today, and we probably don't want to burn that syntax on a full delegate parameter today. There's also probably going to be some discussion point on having that syntax. So for .NET 9, what we want to do is just provide the explicit method that does it, and we would discuss any potential friendliness like an indexer in the future, potentially around C#'s decision for functional interfaces. But that is functionally what this operation is doing. There was a question on whether this should instead be an overload of set slice. Set slice is basically doing a similar thing. It's just saying that for this slice of data, set the values to this. But I thought that there's a somewhat of a conceptual difference between a general filtered update and a setting of the slice. And so it was probably warranted that they be two separate APIs.
And so this is, you have your tensor span, and then you tensor dot filtered update of a Boolean plain thing that has to have the same shape, I assume, comma a value thing that has to have the same shape, and it's for each relative position where the Boolean is true, copy values into X.
Yes, that is correct.
Okay.
Yeah.
All right. Well.
And it's worth noting that for almost all of these APIs, it's not same shape. It is actually compatible shape. And what compatible is that it's either the same shape or it is a broadcastable value. So, for example, filter is allowed to be it is always allowed to contain one element, because that is just a scalar that is implicitly broadcast up to the shape. It's the same thing as why we have in tensor primitives and similar, we have the overloads that take like for max, we have one that takes tensor span x, tensor span y, and one that takes tensor span x and ty, because the t is a convenience to avoid the allocation. And so for tensor span, it's the same concept of you allow a a compatible shape, because it's not just T at that point. If X were a 4x4 matrix, then it is valid for the filter to be a 4x4 matrix, a 1x4 matrix, or a 1 scalar. So it's not just same length, it's compatible length.
Fair enough. Yeah, so again, you've named these parameters X. Doesn't quite seem right. Everything that I see on vector is named either source or vector.
X was done because that's the name we had decided for. Yeah. The X was because for tensor primitives we had said use X for everything. And that was replicated for all of the corresponding methods that were on tensor of T. For these ones that are unique to tensor of T, if there's a better name, I am perfectly fine with it being a better name. The proposal just defaulted to X because that's what everything else was. So if we think source is better here, or tensor is better here, I'm fine with that.
Yeah, I think source in most cases is going to be better, in my opinion.
What are these methods on again? Is this tensor primitives?
These
How
ones
we're
are
looking
on.
at right now?
These ones are on tensors.
No, this is the static tensor class.
The non-generic one.
Gotcha.
Yeah, I mean,
It
I
seems
would
like
go,
on that one we mostly call it input, it seems.
are you looking at the implementation of this, or are you looking at previously
I'm
approved
looking
proposals?
at other APIs that exist in APIs of .NET on the Tensor class. A lot of them are taking a tensor or a tensor
Most
span.
of what's
Yeah,
as input.
that's this, but without being approved.
Yes.
Gotcha.
right. Yeah.
I
None
mean,
of
personally,
Tensor has shipped yet, and most of it hasn't been updated to match API review.
I have to say the very first parameter that is effectively adding as the source for your extension method, I don't think the name matters as much. I think because it's basically not the parameter, right? It's the instance you're operating on, right? Which in most cases, you know, if that is not intuitive what that refers to, then something is really fucked up in the method name. Like the method name which should make it clear that when you invoke it on that instance, what's going to happen. So I would
Yeah, but
say,
it
like,
should
what's more
also
important
make
is the
sense
parameters.
for a static call. They are static methods, really. It's a
Sure, but it's the same thing, right? Even if you invoke it statically, you still see that it's an extension method, right? So if you choose to invoke it statically, that's fine, but you
right.
still know the first parameter is the instance.
I just don't think we have ever just said screw it anything that's this parameter call X. I think we.
No, I'm not saying we should call it X. I'm just saying whether you call it source or input
Oh, yeah.
or it doesn't really matter. Just pick one term and use it everywhere.
Right.
I just don't think it's that important.
So
Like,
does
it's
it?
just
Yeah. Does it modify this parameter? I guess you're saying no because it's in.
Yeah.
Yeah. So source seems good.
Yeah.
It
So
does.
it doesn't modify tensor span. The thing is it doesn't modify tensor span the instance. It modifies the contents of tensor span. That is the elements that the span it refers to get modified. That's why it's in, because the tensor span itself, being a large struct, doesn't get modified, but its contents do.
But if I have a tensor span and a variable called tensor, and I do tensor.filtered update, then that same I don't need to have actually captured the return of this. If I go on that same tensor span and pull the same index that I previously pulled, the value could be different now.
Yes.
Okay.
I thought the reason we return it is because
Right.
we also slice it.
The values that the indices refer to can be modified.
Right. So then I'd probably just call it tensor.
Yeah.
Yeah. It also works.
Okay, looking at what we did on vector, anytime it's taking a vector of t is this. It's either called vector or source. And
Sure.
I think it's source when I'm copying values out of this into something else, and I think it's called vector if it's modifying the vector. Okay.
Yeah, that sounds right.
All right. So my bulk find and replace didn't look for angle brackets. This
Yeah.
isn't axis because it's plural, so axis becomes dimensions.
Well, axes is a plural, right?
Yes.
Yeah, but they said axis should have been dimension. So so axis becomes dimension, and so then is dimensions what you want here for Permute?
Yeah.
Okay.
Yes.
By the way, just for prosperity, if you use abbreviations like RO span rather than read only span, my indexer will probably not be able to link them to the APIs. Just so you know.
Yep. Well, he said it's because he was hitting
Okay.
the
Yeah,
GitHub
if they were used shortened
max.
here, because hitting the GitHub comment length limits.
Jesus, really?
Why do you think it's
Fuck.
taken us 12 hours to get through these proposals?
Yeah, we have like 350 new APIs, not including just like the base, constructor method stuff. It's been a lot.
I mean, take the hint, right? I don't know.
So
Yeah.
you have a note on Permute, change the order of stride parameters, but you don't have stride parameters. Also, why are you leaving notes in your API proposal?
Copy paste over time. It's one that I apparently forgot to remove.
Okay.
So Permute.
But before we go
Permute
further,
is interesting.
it's 11:30 right
Permute
now. So
has.
if you wanna,
I mean, we have we have like 10 method groups to go, and then we're done with Tensor.
right, but then we should make a decision whether we want Booyah to wait or come back because she's sitting here for an hour and a half now. And so if we, I don't think we will finish this in half an hour. Like we might be barely finishing in half an hour, but we will not have time for her proposal, I would say. Looking at our velocity here. Then I will just say let's just reschedule Booyah for next Tuesday. Then you don't have to sit here and wait for us. Does that work?
Okay. Then.
Sorry,
Okay.
it was ambitious. All right, keep going, Tanner.
All right. Permute's a little bit interesting. So, permute, existing terminology that we use in hardware intrinsics and vectors and other places, and it basically means that we're reordering the data. Given a vector, for example, a vector 128 of float, if you were to permute it, you might change the order from element 0, 1, 2, 3 to instead be element 3, 2, 1, 0. So reverse is a type of permutation in which you're changing the order of the elements. Permute here, permute here should probably be called instead permute dimensions. Specifically because what we're permuting is the dimensions within the tensor. And we don't currently have something that says permute elements within the tensor. We could theoretically have one in the future, but that would also potentially be a very expensive API to to implement, just because you're basically doing random memory access over everything. So it might not be something we ever expose. But that was a potential that was a point that needed to be raised of this isn't permuting the elements, but rather it's permuting the dimensions. And we may never have a permute elements, so that's why it was given the name permute there. And so we should make the decision on whether we want to call it permute, whether we want to call it permute dimensions, on the off chance that we were to expose a permute for elements in the future. Now, of course, neither one of them is blocking, because if we were to expose it as permute and then we wanted elements in the future, we could just call that one permute elements. But given how permute works on elements in other APIs, it might be better to just call it permute dimensions, and avoid confusion.
So help me understand what this does. So if I have a two-dimensional tensor and I pass in, like, for dimensions 1, 0, does that mean you basically rotate the like x to y effectively?
Yeah,
Yes.
you're basically you're going from let's say you started with a 1920 by 1080 image, you're changing it to be a 1080 by 1920 image. So
Yeah, okay.
you're doing a transposition at that point.
So it does affect the elements. It's just that it's not individual elements. It's you talk about a whole bunch of elements indicated by the dimension, right? Like it's a bulk update, if you will, rather than
Yeah.
telling something, like a mask or something to that extent, where you say keep those pixels. Yeah. I mean, I don't know. Like, to me, it's like this is one of those things where domain knowledge is relevant. I mean, I think permute dimensions is probably fine in permute elements, because at least it doesn't have any sort of ambiguity of what it does. But I mean, presumably when we do permute elements, it would also have a different signature, right? So it would not just be like we wouldn't have to differ by name either, right? We could just say, or whatever the expression is to select which elements you want to permute. I'm not sure you get away with a read-only span of in there. But
Yeah,
either name is
the
fine.
consideration is that for permute elements, it would, instead of being a read-only span of int, it would be a tensor span of t, or a read-only tensor span of t, rather.
Right.
So I think it wouldn't conflict, but it is potentially confusing to have both of them grouped together, given
Yeah, that's fair.
how they differ.
Yeah, I mean, I think just somebody reading the code, permute dimensions, like putting dimensions in the name, I think just gives it clarity.
And we call it dimensions everywhere else, right? Like, it's not the first time we use the term, right?
It's the name of the
We use the
parameters.
term dimensions. Yeah. We don't really have a concept of higher level dimensionality in most other APIs, because most other things are basically one dimensional, or zero dimensional because they're scalars. And we've not really exposed anything for multidimensional arrays up till this point. Tensor span and tensor is kind of this support for multidimensional data.
Right. So I remember that we used to have this discussion on like rank versus strides versus something like that, right?
Right. Rank is the term that comes from array already, and it's the name that's used in some other libraries. They also sometimes use the term dimension. And then what we call lengths, because it's, you've got the length of each dimension. Some other libraries call shape, but we already use the term less consistently, even for system array. So we opted for rank and lengths. So rank specifies number of dimensions. Length specifies the length of each dimension. And then Here, dimension is basically specifying the index of each dimension that you want to that you're wanting to be in the new position.
So length is basically the same as rank, correct?
Correct.
And then the indices that you specify here as dimensions are also the indices you would use into length to get the length of that dimension, right?
Right.
Yeah, that makes sense.
Right, which is why the 1920 by 1080 dot permute 1 comma 0 then becomes 1080 by 1920 because we're just talking about indexing into the lengths property.
Yeah.
Yeah.
Yeah, works for me.
Yeah. I feel like just while every permute we have is permuting the thing that is one dimensional concept less than what it's doing. So for a tensor, it's the dimensionality instead of the elements. I just feel that permute dimensions, it's different than any other permutes, and just saying this is different. And if you're reading this code, it's not swapping 3 or 4 elements. It's changing what all the indexes mean.
Right.
And so I like the longer name. I think it gives clarity.
Yeah.
Yeah. I also have a preference towards the longer name, personally.
Okay. All right. And so reshape, you're not saying, hey, API review, reshape what lengths looks like here. You're saying the purpose of this is to change the output lengths. You're describing the method.
Yes.
Okay.
Yes. This is a descriptive term of this is changing, for example, from a 4x4 to a 4x4x4, or you're literally, or no, sorry, not a 4x4 to a 4x4x4. You can change a 4x4 to something like a 2x8. So the flattened length has to be compatible, but you can say the actual shape of it is per dimension is no longer compatible. So
the product of all the lengths has
you
to be
can
the
choose
same.
any permutation of. Yeah.
So I do think we have an inconsistency here with the method is called reshape and the parameter that it deals with is called lengths. I mean, I'm not a big fan of the parameter name lengths anyways, and I know that's decided on that, but it does seem kind of odd to me that the method that interacts with it is called reshape.
What would you call it? Relength?
I mean, that's kind of how I feel about the parameter name lengths in general, but
Well, I mean, I think the reason why you would call it lengths is because it is indexing into the length property of the tensor logically, right? So in that sense, it kind of makes sense.
well, no, I'm talking about the property name itself, but
Yeah. So you still think shape would be better because then reshape would make more sense?
reshape would make more sense. And the other issue, someone raised this in the last issue we posted after, I think it was after the last API review, is that in math, right, length can refer to the length of a vector, which we already have a vector.length method in system numerics that does something different than just the lengths. I'm not meaning to bring it up here. I'm just saying we do have an inconsistency in here. And, if we have time to talk about it at some point, great. But I do think we have this weird situation.
I mean, we do. I mean, I don't want to discount what you're saying. It just seems like unless you have a proposal to make it all consistent, I think it's kind of like an impossible task because depending on how you look at it, given that, Tensors has to work inside of .NET and .NET has a definition for what these things are already that doesn't clearly bridge to tensors, it's always like you have the inconsistency somewhere. You just choose where it is. I don't think there's at least I'm not aware of a proposal that would remove it entirely.
Right, and then the other consideration that played into when we were making the decision on lengths is that C# a while back, and even other languages, I think it does as well. They actually use the length property in addition to an indexer existing to determine should this be treated like a collection type. And so you have to be uh, you have to be careful when defining something like a vector 4, where there's a domain terminology of, hey, length means the norm or magnitude of the vector. But the most common term that everyone uses across the ecosystem is length, not norm or magnitude, because those are also indexable. So you have to be careful, because now you've got this thing that could expose a length property and that is indexable, but it's not. It is kind of a collection type, even because it contains four. It just always contains 4 items, but the length property isn't the number of elements. It's not the count. And so there's this weird nuance you have to consider already, because the ecosystem as a whole has decided that when you have a collection, length is the thing to mean it. Even in NumPy and Python, they've got this ambiguity as well, where they actually have like 3 APIs that all return the number of elements. And in one case, they call it size, another count. Then they've also got length, and then they also have shape. And you can get all of them can basically mean the same thing and be conflicting with each other in different ways.
Yeah, and I see this the same thing as array.resize, which I was going to say takes a parameter called length, but it turns out it takes one called new size. When you call array.resize, you pass array.resize ref array, comma, array.length plus 5. Like, what you're passing in is a length, and you call resize. I don't see a difference here between passing in a length and calling it reshape.
Yeah, one question I have is like for all of those, like permute, reshape, resize, it seems like reshape has a requirement that the result has to have the same number of elements. So I assume
Yep, that's
like
correct.
what happens for permute dimensions if I specify fewer dimensions than what are currently existing? Is that an error, or is it just get the tensor that's smaller?
It just swaps those dimensions.
I see. So if I specify less, it just leaves the remainder untouched, basically.
Correct. Yep.
I see. And then for resize, what's the behavior there if I specify fewer than are there today?
Truncate.
Same as array.resize.
I see. So they all differ based on what they do when you specify less. Like I guess for reshape, you would throw an error, right? Because you have to.
Yeah, if
Like,
the dimension,
guess,
if the new size you try and reshape to is not compatible, then it throws an exception.
Yeah. And then for resize, it would just be you truncate. So yeah, I think that to me, it kind of makes sense to have it like the way you do right now. I mean, it's a bit weird that dimensions doesn't really exist as a property, so you kind of have to know what it is you're referring to there. But I mean, I think in reshape, I think length makes definitely sense because that's what you logically actually do. And same for resize. I mean, the problem with both operations is kind of you have to understand what it does. And if the industry term for those things is kind of reshape and resize, which I think it is, then
it is.
I would take that over the concern about the parameter names, because I guess if you hit F1 on any of them, there's probably going to be a picture or some sketch of telling you what it is that is happening there, and yeah, that's the thing you have to understand.
So resize, because I brought up array resize, does anybody know why array resize takes the first parameter as ref instead of returning a new one? / do we want an overload here that does the same thing?
I think for array, it was just, what would you do? You would just immediately change whatever the current array points to, right? Because the idea is that because the resizing preserves the data in the array, Like, why would you want the original array? You would immediately assign it, right?
Right. So I'm just saying, we just made a comparison against array resize. This resize has a different shape. Do we like this shape? Do we want both shapes, or do we want the shape from array?
I prefer this shape. The one from array is pretty weird, and it does make it harder to use in the case that you did want to keep the original array. You might have just wanted to, for example, you might have wanted to um, uh, you might have wanted to use it for another input for another piece of data or other things. You might want to say, well, I need a larger buffer that starts with these elements, but then I want to use the original input and have it broadcast up to
Yeah.
you might want to say like resize for the destination and then multiply, in which case the original input you want to broadcast up again. Um,
Yeah,
there's lots of cases where you could, so
I've
you
hit
can
cases where I
achieve
was
what
upset with
is
the
the ref
resize.
one without the expense of it being a ref with this API.
Yeah.
Okay.
You could just assign it over, right? Effectively, right?
Yeah, exactly. I didn't know. I don't know why array resize. Why somebody decided to
I'm
do
not
ref.
100% sure, but I think the resize method in array more or less came from VB. And I think the existing VB APIs that you use have the behavior that the ref one has.
Fair enough.
But yeah, I don't know. Like, I don't think it, to me, that does not mean we have to follow that.
All right. So resize takes a tensor, makes a new tensor that has the requested links, and copies as many values as it can.
Right.
And then,
Correct.
then now you have resize 2.
Can someone give me the quick rundown when we take things as extension versus not? Like, why would we not make that an extension method, for example?
Which one? Resize?
I mean, all of them here,
I
right?
think
Some
the
of them are
difference-
extensions, some of them are not. So I was just wondering what rule we use.
The rule here has basically been that the two APIs are extension methods because that's what they were for vector types. And then the other ones weren't because they aren't on the vector types. There's actually there's this nuance with a lot of the vector APIs where there's most static methods that are doing some kind of operation. There's a group of people out there that want them all to be extension methods regardless. They'd rather do something more infix-like, and so they'd rather do x dot square root instead of square root x.
Right.
And we don't currently do that for .NET. There's opinions on that we should. There's opinions that we shouldn't. And so here it's basically just consistency with how we've done it on Vector, which is that the X2 APIs are extensions because they would have existed on as instance methods had it not been generic. And then the ones that aren't doing a to operation, they're static. That's just kind of been our consistency up until this point.
I personally would like to have more of them be extension methods than not be extension methods, but right, adding an extension method is not a breaking change, but removing one is. So we've opted for that approach.
So by that you mean like just adding this modifier to any of these non-extension method APIs is not breaking?
Correct.
Yep. I mean, if we can explain it to people and they have an intuition of when it holds, it seems fine. I'm not sure I'm in a position yet to have that intuition. For me, it looks somewhat arbitrary right now.
Yeah. And the thing about extension methods is that people have the choice to choose whether they call it statically or via extension. And maybe in an ideal world, you could actually have some kind of language feature that differentiates between this one we really want to be an extension method, and this one should be an extension method only for people who really want a fluent like API. Um, and then we could just annotate things like square root as being this is allowed to be fluent if the users prefer it, otherwise don't let it be fluent. Um, but we don't have that. That's a completely separate discussion. And so right now it's just trying to be consistent with our with what we do on vector.
Yeah, yeah, because most people who use tensor stuff are going to want to do the fluent approach, and so I think we will eventually want to add these in as much as we can. But Tanner said we don't have some of those features yet, and for consistency's sake, we didn't. But
Yeah. Yeah, I mean it seems like a fine example to add it later too if we really wanted to. Like, I mean, to some extent, as Tanner said, the problem with extension methods or feature, depending on viewpoint, is that it's mostly a code style thing, right? There really isn't a reason why one is better than the other. Um,
Discoverability. So is there a reason, or sorry, is there any particular method that should absolutely not be an extension method?
I think it all just comes down to personal preference for the most part. There's some people who want to see something like x dot add y, and there's some people who only want to see it as add x comma y. And both of them are sensible. Both of them are very understandable in different contexts. And it really just comes down to your own personal preference of, do I really want to read this as, x greater than y, or do I want to read it as greater than xy, or x dot square root versus square root of x? I don't think I've ever come across an example where it's very clearly this one makes absolutely no sense to be kind of infix when the first parameter is of type t.
Right. So I guess my point here is, like, as you were saying earlier, you can call extension methods the conventional way if you make everything an extension method. But by like doing, to Emo's point, both, and it's not clear which is which, you're kind of upsetting everyone, right? Like no one's completely happy, like whether they're a fan of extension methods or they're not. Like we're in this weird in between state. So like I don't love like, oh, we're doing this because of historical precedent.
It does.
Like,
it's more, I think, that it's a separate, larger discussion that would probably need its own hour of API review, and we're not going to do that here. So, if we want to do that, I'd be more than happy to be a proposal forward for us to have the more in-depth discussion. But that's going to happen like, middle of November when everyone's finally down, has the downtime to do.
I was going to say March.
A non-blocking API review, have that deeper discussion on the topic.
So why does it require a deeper discussion to approve these all being extension methods than this weird mix?
Because,
like, why doesn't
because as soon as you say it, I'm going to say array is array.resize and array.reverse. Why are we being different here? So let's just take everything that's this and leave it as this, and everything that's not and leave it as not, and try and finish the names of the method so we can be done with tensors.
But these are like all new APIs, right?
So no, they're not. We have resize. Right. We have array resize. We probably have vector resize. Like,
yeah, but we're changing it because it's not void and ref. But yeah, right. Okay, fine. Like, if this is the only way we can improve it in time, then fine.
I'm just trying to minimize the things we talk about so we finish. We have 8 method groups to go.
All right.
Yeah, my goal was mostly to just record it as a thing to think about.
Yeah.
Yeah, I'm fine in general having the discussion. I just really we need to be done with vector, and we only nominally have 6 minutes to go.
Yeah. Well, I was being quiet for the beginning. It allowed us to get through a lot. But, all right. Yeah, we can keep going.
All right. So resize 2 is is modifying. So it's a mutating one. Because resize produced a new tensor that is different, and resize 2 is
no.
mutating. Oh, you're right. You're not taking. This doesn't say dimensions. This says
Resize,
destination.
yeah, it takes a destination.
Okay.
Yeah, because the length is taken from the destination in this case.
So this is just resize
So
2
it
is
works just like copy 2.
Copy 2 with a different shape. Like it's
Yeah.
copy 2
Yeah.
that
So instead of
throws less often?
truncating, instead of stopping if it's bigger.
Yeah.
Yeah. So if whereas copy 2 allows a too big destination and then it ignores any additional elements, resize 2 will resize to fill the destination. And so it basically it's very similar, but it actually considers the additional shape there.
Okay, but it resize 2 is copy 2 but with different throw semantics. More or less.
Yeah.
Okay. All right, and we've done 2 and not into for things like this.
Yeah, just like
I
we
mean,
did for
it's not
copy
copy into.
2.
Yeah.
That's fair. Yeah, just copy never feels like it could be a mutating verb, and resize could. So resize versus resize 2. Again, my brain latched on to, oh, this is mutate it, and this is make a copy, and that's not what it means. So that's all. English is funny.
Sorry, it is not what it means. Why would it not make a copy?
Resize makes a copy. Resize 2 also makes a copy. I thought resize 2 was mutating. Because I just read this as
Gotcha.
tensor span. Wait, yeah, why?
Okay, the
This
other
one
way
shouldn't be inint, right? That's the problem. Is this says tensor span of inint, but it's tensor span of t.
Yeah.
Yeah, that seems right. Right,
Yeah, that should be t,
Okay.
not in it.
Yeah. See, I saw the inits and thought it was shaping, not destinationing. Okay.
Yeah. That makes sense now. Okay.
Yay, we added value. Ish. All right.
Because that totally would have gone in that way.
Yeah.
Reverse is it's permute, but it's specific. It is the specialization of permute that it reverses all of the dimensions, and so you don't have to specify them. If you we, as per the previous, we don't want the optional parameter. We want reverse and reverse along dimension instead. But basically just a specialization of it is a specialization of permute where you just don't have to manually specify all of the dimensions that you want to reverse.
I think, Tanner, I think the way we have it done is permute swaps dimensions and reverse swaps the elements. Is that not right? If I'd have to double check.
So it's reverse elements is what it's doing.
I'd have to double check.
Because then what would that mean of along a dimension?
Yeah, I don't understand that either. Like, what is it? I thought dimension is like up until then you reverse and then you leave the rest or something, but it sounds like you're doing it only in that dimension.
Yeah, maybe I'm just remembering wrong.
Like if you only reverse a
double
single
check to make
dimension,
sure.
I would just call it reverse dimension. I
Michael,
would
do you
just
wanna-
split the along.
I'm pulling it up.
Yeah, and I agree with what Emo
Yes.
just said.
Sorry, what did you say, Emo? I
While
was
Michael,
reading and not listening.
I said, like, if you only reverse a single dimension, I would just strip the word along. So if you say reverse dimension and you specify the dimension whose elements you're reversing, then that seems sensible to me.
Yeah, so the summary says reverses the order of the elements in the
yeah,
input
so it
along the
looks
given
like it's
axis. Yep, so it's reverse element.
So
and
reverse
that means the
reverses
reverse along dimension is reversing elements within the dimension.
Yeah. So logically, that means for a picture, you would either flip it horizontal or flip vertical, right?
Yeah,
but full reverse is flip both.
yeah, full reverse flips 100% of everything.
Gotcha. Yeah, then I would just say reverse and reverse dimension. I mean, that seems like the easiest to understand. Like along
Yeah.
makes me think too hard. It's like, I don't know what that means.
Yeah, because the other alongs were about changing the shape of the output answer, and this isn't changing the shape; it's just changing the values.
Yes.
Why does the third one have a dimension argument?
Because I haven't cleaned it up yet.
Oh, okay.
Because typing is hard.
Yeah.
It is. I'm aware.
All right. So reverse dimension.
No.
Dimension goes second.
137.
Yeah, I think so.
Okay.
For consistency.
Yeah, and those n-ints are going to be changing to the n index for the dimension itself.
On just this one, or all the places? That...
No, it should be across the board.
So all int and inint dimensions should be in index.
We do a find replace.
I'm trying to think if there's any exceptions to that. I don't, since we're splitting out the APIs, right? We're basically moving the sentinel value, and so I believe that will be the case. Were you gonna say something?
Why would it be in index and not just index? Because it's only specifying one dimension, not many. So it would just be index.
Well, what if it's a dimension that's like, what if the tensor for some reason has
More than 4 billion
more
dimensions.
Yeah.
We don't allow that. Rank is already int limited.
Oh, rank is already int limited. Okay.
Which is also why, length is always a regular span.
Well, in-index allows like from end indexing, right? It seems useful.
Yeah.
Like anywhere
So
you can take an index.
yeah, so does index. So yeah.
Oh, I see.
No,
Okay.
index does too. So
I see. You were saying, okay, I misunderstood.
So
yeah,
now
the
I'm
reason
kind of
we want
curious.
index instead of inint is so that you can do from end.
So we don't want this for anything else. Like all the time that we had read-only span of int, for example, we don't want to take a read-only span of index.
Yeah, so like permute dimension, should that have been params span of index?
Yeah. Yeah, those probably should be index.
Why did it take an hour? Why did it take
There's
2 hours
a
before you realized
Notable
this?
cost to using index over inint, though.
Sorry. What was that?
Because there's
Tanner?
a cost to using index over inint, and so there's a cost to using index over inint, and so if we have it, we probably want both, not just index.
Gross.
I mean,
How
so
much
one
is
thing,
the
And
cost?
at that point, someone could just it's actually like an additional branch in computation for every single case, and so if a user really wanted to do from end, they could just use the index method to resolve it themselves for the cases they needed it.
Yeah, I
So
mean,
one thing we should consider is like, because we've done this for collection types, right, where the compiler has effectively a specialized lowering rule when you use the head operator on things that take ins and are enumerable and take count, blah, 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 right? So one question is like, could we generalize this somehow with attributes or some other weird pattern where the compiler could just do that? It would be
Yeah,
worth just
that's something that's
typing it
going to
out
be
because,
discussed more for .NET 10 and
yeah.
be next.
okay, so
I'm asking because I'm not a fan of just duplicating everything with
yeah,
index and int.
yeah,
Before we go down that path, I would do the other thing.
yeah. I think the answer is they're int. And
So
then
then, question with that, right? In a lot of these
Yeah.
cases where we take the
Int
int,
is
we
the
take negative
faster.
values to mean from the end. Do we want to keep that behavior? Right, because say for example, you have a picture, right? And you
Well,
want to do
that's
something
not
with just
how
the last
int
two
works. That's how
dimensions.
index works.
I know
Yeah.
that's how index works, right? But that's what is happening in some of these cases.
Does that mean the branch is happening regardless, like whether you're using an int or an index, if it's checking for negative values?
It would happen for some of them, not all of them.
So I'm not sure I understand what you're asking, Michael.
And,
Because
I
you said
think
that you
that's
said
where
like
the
when they keep
implementation's
the
likely wrong,
behavior.
because
Yeah, so like for example, so for some of the ones that take an int, right, int dimension, right? If a user provides a negative value, we've interpreted that to mean from the end.
Oh, I see what you're
So
saying.
we're basically
Yes.
doing index behavior, right? And
Gotcha.
we can remove that because it is adding an extra step or an extra path, whatever it may be. I was just saying, do we want to keep that behavior or not? Because the reason we added it in the first place is there's a lot of time in tensors where you don't really care about the larger dimensions, right? If you have a batch, for example, you don't care. You just want to, invert the image from X to Y or Y to X. And so if there's
Right.
one image or 10 images, you don't care. And so if we don't have that negative behavior or that index from end behavior, then the user has to say, oh, give me the dimensions that I want to swap are lengths at, length -1 and lengths at length -2 or whatever, right?
So I would say don't have that behavior because removing that is going to be virtually impossible, right? Once you ship it, that's a behavior you have to support forever. When we discussed indexing originally with the C# team, I mean, to be clear, like range and index came from our conversation of supporting tensors in the long run and have Python-esque syntax for that. And one of the discussion points was, should we just say, fuck it, you just have negative indices? And the conclusion was we don't want to do that, basically because of math issues, right? Because if you fuck up your computation, you might have negative values by accident, and then all of a sudden, like, you just take from the end, and people are super confused by that behavior. So
Yeah.
I would say if you strongly feel you want the indexing from end semantics, I would suggest either just bite the bullet and add index as the parameter type, or do what I suggested and at least consider whether you can somehow express statically the lowering pattern that the compiler should use so you get away with int, which is already what's happening for some of the collection types, right? Which I don't know, that might just be a function of like, oh, we need to add this attribute, teach the compiler about that attribute, talk to Jared, and maybe he's okay with that, right? I would prefer that over duplicating everything and take index and int. That seems very unfortunate.
Okay. Well,
But
then why don't we take an int, remove the negative behavior, and then if we can't add that attribute later on, next year or whatever, we could have another meeting to discuss how we want to handle it. But that way, we're not
perfect,
blocking
yeah.
ourselves or anything.
Yep. And the user can always help themselves by adding an,
Yeah.
I guess,
And
yeah, they can add an
the
overload,
other
right?
reason why we couldn't. Yep. The other reason why taking the negatives was undesirable is because there's many places across the BCL where negatives are used as sometimes as a sentinel value, and so based on the original proposal before we said expand it out into reverse and reverse dimension, the -1 didn't mean from end. It meant
Yeah.
Yep.
No dimension.
it meant reverse for all. And so that was already an incompatibility across our APIs and potential confusion. So
Yeah, and
taking
we have that
negatives
same
to mean
behavior on
negative
like.
integers to mean from end in general is a bad behavior for us.
Okay, yeah, I'll make sure I'm not using it anywhere then, because we have that same, like you're saying, sentinel value behavior for squeeze right now, which I think we decided we wanted to expand out as well. But anyways, yeah, you're right, Tanner.
Okay. All right, so we got reverse and reverse dimension.
Okay. Sequence equal. Sequence equal is same as on span. Regular equals needs to. It's on span. It needs to throw. Same as get hash code. So we want a sequence equal API that explicitly says I'm doing a sequence equality operation. It is where t is I-equatable, and it will always use the default comparer, whereas the equals method that returns the tensor and therefore does element-wise is doing it via the I-equality operators, generic math-wise, because equals and operator equals are different for some types.
Yep. Parameter name span, parameter name tensor, parameter name don't care.
Set
Okay. Sounds like span's good enough.
It was, yeah. I don't really care. We've got set slice.
Is tensor,
which, like I described earlier, it's kind of like a filtered update, but instead, oh, go ahead.
Your tensor, the class tensor, extension methods don't work across conversions, so it doesn't get a sequence equal. Is that what you want?
I think that's what we want because we also don't have a sequence equal for array. Sequence equal is only on span.
Okay.
We should have sequence equal array.
Set slice, like I described earlier, it's similar to it's similar to filtered update. You're just not specifying a bool per element you want to update. Instead, you're specifying a range of elements that you're wanting to set. And so set slice, it's functionally saying slice tensor using these ranges and copy to you're saying slice tensor to the range and then copy values to that slice.
For each range and ranges values dot copy to tensor of range, basically.
Yeah, that sounds right.
Okay. Yeah, I mean I really, 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 really wish we had an attribute we could put on params that says no zero. I feel like everywhere we have params, we want no zero. But params allow zero. Anyway, yeah. The parameter order does feel backwards to me. The question is, do you think params is important?
Given that you can have an arbitrary number of dimensions that you want to slice along, I think that it's overall consistent for the experience. But yeah, it's this weird case. We could fix the order here if we were to say that we expose an indexer instead, where it is indexer params ranges, taking a tensor span as the set value. And then you can have the nice syntax of tensor range equals values, which is how Python and some other languages do it. But that was a kind of new concept that was more advanced, and so we didn't want to cover it as part of the first proposal since it probably required more in-depth discussion. But if we did want to say or reorder it here so ranges wasn't params, I would think that we would want to have that version exposed so that we could still have the friendly params like
Right.
syntax for users.
But with the new free floating square brace syntax, like params doesn't really buy you much.
That's fair.
Like set slice, open paren, open square
Well,
bracket,
Yes,
range, close square bracket, comma values is the same as set slice values, comma no square bracket. Actually, in fact, it's now optional square bracket. All the rest of your ranges. I'm just saying, params. The params versus not C# syntax wise is much less of an important thing than it was back in .NET Framework 1 days.
I agree, and the non-params is like a lot more readable in a lot of cases.
I think it's
like
so I think that in that while there is slightly less, there is still the consideration of versioning where params has significant benefit because params is not always the most optimal thing to take. There's many cases where if you know that there's only 1, 2, or 3 ranges, which are also typically going to be the most common number of ranges passed in, or elements in the case of any params, you can specialize and optimize the implementation. And so even if we had params span, in .NET Framework 1.0, we would still have had string split that took a single character as a dedicated API because of the perf implications of having that dedicated API. And there's many cases where correspondingly having params means that you can now expand to have overloads that explicitly take 1, 2, or 3 parameters as explicit non.
just end the meeting.
Did Teams just die for everyone?
Emo pushed the wrong leave.
It's really funny. Yeah. I don't know. Like, nothing's stopping you from doing the other overloads without params other than framework design guidelines, perhaps.
It's not just framework design guidelines. It's you can end up with conflicts because the parameter order matters in how they're interpreted.
Anyway,
And so if you have something that is conceptually a params and you want it to be paramsable.
I mean, it works, right? You can just say if you want more than one split, right? Like you have to pass in a collection explicitly, right? Like params is syntactic sugar. Like it's you want it or you not, and having params leads to more possible, compilation breaking changes because there are more ways you can call it.
And I agree. It does set up for doing
Right.
interceptor functions of.
But
We
the
take
issue,
like a special 7 instead of a. You called it with param 7, but like, and that's fine. I'm just saying you don't have to say we need the indexer if we feel that ranges should go earlier in the order here, because we need to put param somewhere. You don't. So if you think the order is ranges comma values, then we make it ranges comma values and lose the params. And if you think the params is important, then it is what it is. So I'm just. You left the comment here. The ordering is weird, so I'm asking, do you care about params? You're not gaining the indexer because we don't have enough people to approve it. So,
yeah,
if that matters to you, then
yeah,
you don't get the
params
indexer.
I think is over. Yeah, I think having the params is more important than the ordering here.
All right. And in range is correct. This is the first time we've seen anything with a range, and we already had the index discussion, but just asking.
Yes. Yes, because...
Okay.
Yep, in range is correct here.
So split.
Yeah, Michael, do you want to describe this one?
Yes. Do you want to? I'll pull it up in the code because the screen share's gone.
Oh. I'll share. I'm not used to, the meeting leaving in the middle.
Yeah. I mean, basically, it splits the tensor into multiple tensors. Let's see. I think. Okay, yeah, it splits the tensor into multiple subtensors. You give it the number of splits and the dimension you would like to split it on. If the tensor and the dimension cannot be split evenly, then it throws an error. So say it's like a 1/2, or well, say it's a 1/3, and you say I want to split on dimension 1 with 2 splits, it'll throw an error because you can't split 3 into 2 even tensors.
Fair enough. Why is num splits an inint? Oh, because you think you're going to have an 8 billion item and you want to split it 8 billion ways?
Hopefully not.
Turns out you can't have that many if you're returning an array. Num splits is going to be array.length, right?
Yes.
So it feels like you're just int.
Yeah, that should be fine.
Should that be called split count instead of num splits?
That works too.
Yeah, that looks better.
Yeah. So squeeze, that's the kind of domain-specific terminology for what's happening here. If you, so this is going to be expanded out, but if you specified a dimension, then what it's basically doing is saying remove this specific dimension, and squeeze otherwise says find all the dimensions of length 1 and removes it.
But the dimension, if you specify one, it still has to be of length 1.
Right. So does that become a conditional squeeze then, or does that become a throw? It wasn't 1.
Throw it wasn't 1.
So that feels like it's squeeze and squeeze dimension. Unless you think a long makes sense here, but
or squeeze all and squeeze dimension maybe.
We didn't all the other ones. Like we didn't say reverse all versus reverse dimension.
Okay.
So we can go back and add the alls, but
no, I'd rather not have them. I don't need them.
Since that one throws, since the squeeze dimension throws, do we want a try squeeze dimension on top?
Not a bad idea.
It's basically just a question of should users be validating the dimension is length 1 first, or does the API do it for them?
I mean, the other option is it doesn't throw, just that it gives you back the same tensor if it wasn't 1. I don't know which one you think is better, because presumably if you give it, if you just call squeeze and nothing's
confusing.
But if nothing's dimension 1, this gives back the same tensor, right?
Correct.
Right.
So I mean, no matter
But then the
what, it's
difference
inconsistent.
between those is you're saying specifically squeeze this dimension.
Fair enough.
Yeah.
Um,
I guess I guess I'd be fine with saying that you squeeze it and it can't be squozen, so therefore it returns
unsquoosed.
it as is.
I mean, I think you should throw an error because if you are if you're specifically trying to squeeze a specific dimension, you're probably trying to do something specific after that,
Yep.
right?
Sure.
And
then I would
Yeah.
say start with the throwy kind, and if people say that writing an if in their code is too much, then they can write a different if with the try.
Sounds good to me.
Just going on the KISS principle. We can see the end.
Yeah. Unsqueeze at the bottom is then the inverse of that.
So that's insert a dimension
so,
of length 1 at a particular dimension.
Yep.
Fair enough. So should that be unsqueezed dimension for parity, or does unsqueeze only ever make sense if you specify where you want the unsqueeze to happen?
So
It only makes sense if you specify.
Okay.
the default behavior in Python is that if you don't specify, it assumes you're trying to add like a batch dimension. It adds it at the very beginning. Either way is fine here, whatever approach we take, but that is their default behavior.
Okay. But it would just be that unsqueeze is unsqueeze 0.
Yes, correct.
Yeah.
But we're not going to add it.
All right.
Yeah, we'll let people specify
Yeah.
0. I mean, we could default this if you want. So then you would have unsqueeze as dimension 0 and unsqueeze comma
I think it's
3 is-
clearer to specify it.
All right. Defaults can be added later. But you can't take them away.
And sorry, and what's the default behavior for squeeze?
Yeah.
Oh, whatever. We can move
The
on.
default behavior for squeeze is to remove everything.
It
Everything
removes
that's
all
dimension 1.
dimensions of length
Yes,
1.
sorry. All dimensions of length 1.
Okay, got it.
So squeezing a 2x2 returns input, and tensor, but squeeze dimension on a 2x2 comma 0 throws, and squeeze dimension 2x2 comma 1 throws, and then squeeze dimension 2x2 comma any number that's not 0 or 1 throws for a different reason. So squeeze is find anything you could squeeze, and squeeze dimension is that one. And unsqueeze is insert.
And does the dimension have to have length 1, or does it like truncate?
Has to be of length
Stack
1.
is
Yeah.
based.
Cool. All right, moving on. Thanks.
It's
for
basically
answering. I know-
saying find the dimensions that aren't actually meaningful to the data and remove them.
Cool.
Yeah, you can kind of think of it and that like if like in the same way that 1 is the same as 1.0 or 0, 1 or 0, 0, 1, they're all the same number 1. A 2 by 2 matrix is also a 1 by 2 by 2 matrix and a 1 by 1 by 2 by 2 by matrix. You have an infinite theoretical number of 1 dimensions that precede or that could be intermixed between the data.
So are you back on squeeze, or are you talking stack?
No, I was finishing explanation of squeeze there.
Okay.
So stack is a parity to concatenate, whereas concatenate does appending of data. Stacking does stacking of the tensor dimensions. And so we'd have stack and stack along dimension for these.
So I don't understand what stack and concat. I would understand concatenate and prepend, but I don't understand what stack means at all.
So stack
Max,
essentially,
do you think you can explain it better?
yeah. So stack inserts a new dimension and puts it along that axis. I mean, you could almost see it as like I mean, it's not really like a convenience method over concatenate, but like for example, if you had 10 images and you wanted to put them all into one tensor, you could say stack these 10 images on axis 0. It'll add a new dimension at axis 0 of length 1. It basically unsqueezes at dimension 0 and then concatenates them all along that dimension, so you get basically 10 images on top of each other.
But I thought that's what
Oh,
concat
so
did.
it's unsqueeze. No, it's unsqueeze and
It's
concat.
Yes, it's an unsqueeze and concat, whereas concatenate does not have that behavior. And so concatenate can do different things because it's not adding in a new dimension.
But when we talked about concatenate, the description was if you call concatenate with 3 images, you now get back a tensor that is 1920 by 1080 by 3.
But it had to have the right dimensionality to begin with. It would have had to have had 3 dimensions, right?
Yeah. So with concatenate, if you have 1920 by 1080 by 1, you could catenate on the 1 and get a 1920 by 1080 by 3.
Okay, I missed the by
It,
1 when we were talking about concatenate then. Because I
yeah,
thought that was the difference
stack
between concatenate and concatenate along dimension.
concatenate along dimension. So basically concatenate along dimension. So say you have like a two by two I mean tensors, right? Matrix table in Excel, whatever you want to call it, right? With concatenate with along the dimension, you can either say like extend the rows and add them to the right, or extend the columns and add it below, depending on the dimension that you're concatenating those values to.
Right? And what does the dimensionless concatenate do? Just concatenate of a 2 by 2 or of two 2 by 2s.
It would just add the values to. So for a 2 by 2, I mean it's kind of a bad example, right? It's kind of like 2 plus 2 equals 2 times 2 equals 2 squared, right? You have that same behavior with a 2 by 2. It would add it to the end of the rows. But like it would be differing behavior, for example, if there's 3 dimensions you try to concatenate just because of how the memory stuff works.
So
But it eventually just adds. So if you concatenate with no dimensions, it adds all of the values from the second tensor just linearly to the end of the values in the first tensor.
okay, so concatenate and concatenate along 0 are the same thing.
I mean, can concatenate ever throw an error if you don't have the right number of dimensions? Yeah. So like the thing is like it works if you've already unsqueezed and then you concatenate. But like otherwise,
Fair enough. I just
you
the impression
like
I got from
concatenate never adds
concatenate.
dimensions.
I thought concatenate that didn't take a dimension. My understanding was that one was supposed to invent a new dimension and create them along that dimension, which it sounds like that's what stack does. And so then I don't know why we needed the along dimension suffix when
So
it's really just
So
we're
it-
specialing
So
zero.
concatenate without a dimension flattens the two tensors and combines them linearly. That's what concatenate does without a dimension. With a dimension, it doesn't flatten the tensor first. So flatten on dimension 0 is different than flatten without a dimension. Or sorry, not flatten. Sorry. Concatenate without a dimension is different than concatenate along dimension 0 because concatenate without a dimension will flatten it and concatenate on dimension 0 will not flatten it.
Am I correct to say that concatenate requires all the arguments to have the same dimensionality and will never change the dimensionality of the result from its arguments?
It requires that the dimension that you are concatenating on be compatible. So for
Okay.
example, you could concatenate a 1 by 2 to a 2 by 2, right, along the dimension of length 2, but not along the dimension of length 1.
And then does it repeat itself for each dimension it doesn't like care about?
Yeah.
Like, so, yeah, okay, got it.
And then I assume we actually want these to be params so that stack and concat look alike.
Yeah.
And then I think the righty one we left alone. Yeah.
Yeah, that sounds right.
Okay.
Last three APIs. ToString is a the consideration here is that we have a collection of arbitrary length. We don't necessarily know how many dimensions there are. People are going to want to ToString it. The most common thing is they want to be able to see what is the values that this tensor contains. And so they want to see the actual data. They don't want to see just, system.array. But we also can't just create a buffer of unknown length. There's DDoS concerns. There's other considerations. So we want to give users the ability to say that for a given dimension, we want to print no more than we don't want this dimension to be longer than this length, and anything else we just want to leave as ... And so this basically gives you that functionality. You can say, so if imagine this were.
Oh, sorry.
Go ahead.
The lag is tough, but is this? It's still ON, right? Like there's no like sparse representation of the tensor. Like ToString is still going to be proportional to like the amount of data you feed it. I'm not sure. Like, what's the DDoS concern?
Because you could make a tensor.
It's instead of saying loop over all elements instead of looping over all elements of all dimensions. So let's say you just had a 4x4. If you said 2, 2, it would only print the first two elements from. It would basically print the first element, the second element of the first row, and they would comma ... and then it would print the first of the first two elements of the second row ... and if there was any rows after that, it would just leave that as ... And so it allows you to say, I only want to print a subsection of the tensor, so that way I can at least bound how much computation might happen here.
Which is still like ON. Like, even if everything was like init max value, like it's still never going to be more than the size of the data, like the work, right? Like I buy that, like having this is useful in a notebook and stuff, and when I just want to see the first few elements in each dimension. But I also think that like when I'm working with small tensors, I don't want to have to write out the maximum lengths every time. So unless there's like a real security concern, like can we also have a ToString that doesn't take maximum lengths?
There's a default ToString, and it will have sensible defaults that will be reasonable enough for use in like the debugger. Okay. But for anything beyond that, we can't have the default ToString just be doing unbounded string building. We want to string to a reasonable default and then provide an overload so users can provide their own defaults, or generate the full tensor if that's really, really what they want.
Fair enough. I wasn't thinking about object ToString and how everything in the world calls it. Yeah. Okay. Cool.
So, chat points out
right, and that's the real issue, is that it's object ToString.
Is that because this is params, you can think you're calling the params one with 0, but really you're calling the other one. So this is calling whatever ToString is on read-only tensor span, and then this is doing something else. So is that what you want, what you expect? Do we care?
Right, that's calling the object overload. Right. Oh, no.
Well, once I put the 2 in, it's calling this one. Not putting this in is calling the other one.
I think that's probably fine.
Okay. I assume there are rules on what lengths looks like.
Yeah, it has to match the same, like the number has to match.
You have to get the rank right.
Yeah, the rank has to match. And I don't remember if we care if you specify larger
Yeah.
or like I don't remember if we specify like, hey, it's a 2 by 2 tensor and I said give me 10 rows and we just stop after 2, or if we throw an exception. I can't remember the behavior that we have for that.
Okay. And once again, I'll ask, you're doing extension methods on the span ones, but not.
We typically stop.
Okay. Uh, do you need one of these for tensor as well?
Yeah, this one should actually have a third overload for tensor. Yeah, this one in particular should have an overload for tensor.
Okay. I'll just name them all tensor.
Transpose is the one that I was trying to describe reverse as earlier. It's the one that it's the one that does the permutation and reverses the dimensions. So it just says given all dimensions by default, reverse them. Reverse the order of the dimensions. So instead of row column, you can become column row, or etc. for higher dimensionality. ABC to CBA.
Fair enough.
And then the last one, try broadcast 2, it is a try version of the broadcast 2 API, in the same way that we have copy and copy 2 and try copy 2, for when the destination buffer's too small. And with that, we'd be done.
Okay. Guess the only thing is, I'll say everything else is named tensor now. So these two will just be called tensor as well.
Yep, that seems good to me.
Yeah, so broadcast, they got source and destination, but everything else got, I guess, try broadcast 2, I guess should call them source and destination as well. Unless we want to rename broadcast to just call everything tensor. Okay, and then I guess the is-pow-tos would stay X because on generic math we probably called it X. So, all right. Any final words?
Yeah. I'm glad we're done reviewing this.
Yeah. Remember 2 hours ago when I thought we were already done? Man, I was dumb.
Barely. All right.
All right.
Seems like forever ago.
And yeah, I guess 12:30 for 2 items, and it's 12:45 for 1. So all right, Tensor's done. Happy .NET 9ing.
All right. No more tensor proposals, right? Okay. Till next year.
Yeah. All right. Well, anybody who stuck through all that, thanks for being here. Some good things got pointed out, especially when we introduced generic ambiguity. And yeah, I won't be here, but the meeting will be next Tuesday for same .NET time, same .NET channel, where we'll find out how emo feels like hosting off of which laptop and in which room. So, all right. Good weekend. If you're a Seattleite, don't melt. I think it's supposed to be cooler today. And yeah, see you all around. Auf Wiedersehen.
Yeah.